yes, more math. Okay, so today this will be China West Mathematical Olympiad 2009 problem number 3. You can find it in AOPS contest collections, but the problem statement is, so you have triangle ABC, D is the midpoint of BC, H is its orthocenter, and then E and F are points on AC and AB, such that AE equals AF, and EHF are collinear. After that, it let ray DH intersect the circumcircle of ABC at the point P. Then it asks us to show points A, E, F, P are concyclic. So, yeah, so when you're drawing the thing, since AE equals AF, then that means EF is perpendicular to the angle bisector of this angle. So yeah, so that's how you draw E and F easily. And then, yeah, so P. So one of the first things I noticed is that, you know the thing of the spiral similarity when you have two circles? Hold on. So yes, when you have two circles that intersect at 2 points A and B, and then you have two lines passing through B. This one, yeah, let's label them circles gamma 1 and gamma 2. So yeah, so you have circle gamma 1 and gamma 2 intersect at two distinct points A and B. And then if you draw a line through B intersecting the circles at C and D, and then another line through B intersecting the circles at E and F, then we have through a quick angle chase that triangles ACE and triangles ADF are similar. And then also triangles ACD and triangles AEF are similar as well. Here we can see angle ACE is equal to, I will use directed angles. So yeah, directed angle ACE is equal to directed angle ABE is equal to directed angle ABF is equal to directed angle ADF. Or for normal angles, ACE, 180 minus ABE, ABF, ADF. And you get similarly AEC equals AFD. And then you can also angle chase for the other pair of similar triangles. So going back here, if these two circles intersect at points A and P, and then look, we have a line through one of the intersection points and another line passing through the intersection point. So that means that we must have triangles PFB and triangle PEC are similar. So I thought having a pair of similar triangles is already, like from the start, is already a big amount of info. It's a nice amount of info. So I decided to define P prime as the second point of intersection of the circle of AEF and ADC, and to try to prove that P prime lies on line HD, as shown by my dotted line, because it has not been proven yet. So when you're trying to show collinearity, sometimes it helps to put a dashed line instead like that, so that you'll remember that you haven't actually shown they're collinear yet. Otherwise, you might accidentally use the fact they're collinear and go in a circular argument. Anyway, so first of all, after thinking about it for a while, I noticed that AE equals AF means that A is the midpoint of arc EP prime F. Hence, AP prime is the external angle bisector of angle EP prime F. And then I also know, because supposedly where the ray DH intersects circle ABC, that is a well-known point, sort of. It's appeared in many problems before. I call it as the MH point. I don't know what other people call it, but yeah, it has some interesting properties. And one of those interesting properties is that if you intersect the MH point there, this should be a 90-degree angle. The proof for this is that it's well known that when you reflect the orthocenter over the midpoint, let's say to point A prime, reflect orthocenter over the midpoint of a side, it's well known that this lies on the circle and that this is a diameter. So because this is a diameter, this angle would be 90 degrees. And that's the proof for the MH point forming a 90-degree angle there. So hence, we need to prove that this is 90 degrees. We don't know it yet because instead of defining it as this, we defined it as the intersection of the circle. But then, since this is the external angle bisector of this, for these two to be perpendicular, this should be the angle bisector. And then I was like, I tried looking around for a way to angle chase, and it seems like you can't angle chase it because the angles here are really random. You don't know the arc AP on the big circle or the small circle. It's not really that nice for angle chasing. But then, I thought, so how else do you show angle bisector? Well, angle bisector theorem. So, show that P prime F over P prime E is equal to FH over EH. FH and EH are bound pretty close to triangle ABC, so that's okay. But then P prime F and P prime E are pretty random. So how do I change their ratio to something more related to triangle ABC? Well, remember what I said earlier? Triangle P prime FB, similar to triangle P prime EC. So that means that P prime F over P prime E is also equal to P prime B over P prime C. But that's still not that closely related to triangle ABC. So instead, we use the other pair of sides. It's also equal to BF over CE. And now we need to show that BF over FH is equal to CE over EH. Now, how can you show that? Look at it closely. I wonder. The two triangles look similar. So maybe we have to show that they're similar. And yes, one can quickly check because orthocenter. This is 90 minus angle A is equal to this. So that's already one pair of equal angles. And then the other pair is already obvious from the fact AE equals AF. These two angles are equal. So BFH and CH are both equal to 180 degrees minus these two. So they're equal. So we already have our pair of similar triangles. Nice. So then after that, so we already have PF over P prime F over P prime E is equal to BF over CE from the first pair of similar triangles. And then this is also equal to FH over EH from the second pair of similar triangles. So we already have that this is an angle bisector and this is 90 degrees. And then so that means that P prime is the MH point, which we already know lies on the ray DH. And then so when I wrote the formal solution to this, I instead let ray P prime H intersect here at A prime. Then I first showed that this was 90 degrees. After that, stated that because this is 90 degrees, this is a diameter. So these two, well known to be reflections over this. So D also lies on that line. And that's how you prove China West Mathematical Olympiad 2009 problem 3. So you first have triangle P. You first intersect the circle P prime, get your first pair of similar triangles. After seeing what should be true by the angle, after that you notice that this should be an angle bisector. You get your next pair of similar triangles. After that, use a well-known property of the MH point and you're done. And thanks for watching. Spiral similarity. This comes in handy, and the MH point. So remember them.